Hi ladies, this is lesson 4.3. It's triangle inequalities. So the last lesson, 4.1 and 4.2. In 4.1, we're dealing with triangles, but we're dealing with the sum of the angles. In 4.2, we're still dealing with triangles, but we're dealing with the congruence of the sides and the angles. So we had a couple of those new definitions, base angles and legs, and we said that in isosceles triangles specifically, that those are congruent. But in this next lesson, we're talking about inequalities. So if you remember from 4.1, we had that auxiliary line. So we're going to kind of use something similar to that in order to form what we call an exterior angle. Okay, so first we've got a few definitions. Exterior angle, adjacent interior angle, and remote interior angle. So let's start just by defining these terms, and it might be helpful for you to look at that diagram that's on your demo sheet. I'm just going to make these a little bit smaller so that I can reference them as I'm writing. Okay, so your exterior angle, you can see that here. This angle right here, that's your exterior angle. So an exterior angle is an angle formed by extending one of the sides beyond the vertex. So in this example, one of those sides is extended beyond the vertex. This side, here's the vertex, this side goes beyond it. So that forms an exterior angle. And it could be any side beyond any vertex. So you could also extend this side beyond the vertex, and this would be an exterior angle. You could extend this side beyond the vertex, and this would be an exterior angle. So it's really any side that goes beyond the vertex. Okay, the second term is adjacent interior angle, and you can see that here. This angle is the adjacent interior angle. So the adjacent interior angle forms a linear pair with the exterior angle. It's going to be inside the triangle, but it's going to be right next to the exterior angle. So shares a side and vertex with the exterior angle. And is inside the triangle. Also, it forms a linear pair. With the exterior angle. All right, and then the last term is the remote interior angles. So here are our remote interior angles. So they are inside the triangle, but they're the two angles that do not share a side with the exterior angle. So angles inside the triangle. And they are the two angles that do not share a side with the exterior angle. All right, so we've got a triangle inequality conjecture. And this says that the sum of the lengths of any two sides in a triangle is greater than the length of the third side. And we'll look at applying that in just a second. But another conjecture we have is the side angle inequality conjecture. So in a triangle, if one side is longer than the other side, then the angle opposite the longer side is longer than the angle opposite the shorter side. So if you wanted to just do this little experiment, you could draw any kind of scaling triangle, any triangle that has one side that's longer than the other. So in this example, MS, this is longer than LM. So if one side is longer than the other side, then the angle opposite the longer side, so that's talking about this angle. This is the angle L, is opposite the longer side. The longer side is, this says longer, this should say larger. Larger. So angle L is opposite the longer side, so that angle is larger than the angle opposite the shorter side. So LM is the shorter side, so angle S is shorter, and MS is the longer side, so angle L is longer. So that will be true with any triangle. So any kind of scaling triangle you draw. In this example, here's the shorter side, here's the longer side. That means that this angle, angle L, is larger than angle S. So you could do that with any triangle, use your protractor, use a ruler, just to kind of experiment with this conjecture, but that will always be true. Okay, and then the last angle conjecture that we have is the triangle exterior angle conjecture. And the triangle exterior angle conjecture says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. Okay, so let's look at this for a second. You need to refresh what the remote interior angles are. Go back to your note sheet. The remote interior angles are the two angles that do not share a side with the exterior angle. So they're inside the triangle. So in this case, angle C and angle A, these are your remote interior angles. X is your exterior angle. And while we're at it, we might as well just label B, which is your adjacent interior angle. Okay, so this is saying that angle A and angle C add up to be angle X. Okay, so let's think about this for a second. Is our triangle sum conjecture says that A plus B plus C equals 180. Okay, so we know that's true. It also says that B plus X equals 180. We know this is true because of the linear pair conjecture. So this is the triangle sum conjecture. And this is our linear pair conjecture. So if we combine those two conjectures, this gives us X is A plus C. Okay, because B plus A plus C has to equal 180, and B plus X has to equal 180. So we could substitute in A plus C for X. So that's what this triangle exterior angle conjecture is saying, that the sum of the remote interior angles is equal to the exterior angle. All right, so let's redirect move our attention now to that extra example. And these extra examples a lot of times are, finding the value of X, so we have to use a little bit of algebra too. But we're going to try to use the new conjectures that they give us in each lesson. So try to always apply exactly what you've just learned to these extra examples. All right, so in 4.1, we had that triangle sum conjecture. So you can use that here, or you could use a linear pair conjecture to get your exterior angle. So either way, either one of those will work. So here, if this angle is 100 degrees, what do we know about this angle? It's a vertical angle, so it also has to be 100 degrees. And we can take the sum of all of our angles and use the triangle sum conjecture. And if we do that, we get x equals 50. So that's one way we could do it. Another way we could do it is by getting an exterior angle. So if we get an exterior angle, we can use a linear pair conjecture here or here, it doesn't matter which way. But we would do that to get an exterior angle of 80 degrees. And then we can use that conjecture that we just talked about, the triangle exterior angle conjecture, that says the exterior angle is equal to the sum of the measures of the rate of interior angles, which are these angles here. So 80 equals x plus 30. And we get the same answer. X equals 50. 80 minus 30 is 50. So either way, you can use either one of those methods, but trying to apply what we just learned, the triangle exterior angle conjecture, is going to be the one in red, the second way we did this. All right, and then just as a closing question, the lengths of two sides of a triangle are 11 centimeters and 25 centimeters. Which of the following could be the length of the third side? Okay, so I always draw little diagrams. They're not necessarily to scale, but just so that you can see. Okay, 25 centimeters is one side, 11 centimeters is another side, and the question is, what could be the length of the third side? Well, we have a conjecture. The triangle inequality conjecture says that the sum of the lengths of any two sides of a triangle is greater than the length of the third. Okay, so the sum of any two lengths, so 11 plus 25, has to be greater than, we'll call this C. So 36 has to be greater than C. So that means C has to be less than 36. So it's not C, and it's not D. So you can narrow those two out right away. Now, it could be 25 or it could be 14, but it has to be true with all sides. So let's say, we'll just start with A because that's first. If this is 14, then 11 plus 14 has to be greater than 25. Is that true? No. It is not greater than, it is equal to 25. So this cannot be 14. So let's try 25. So 11 plus 25, is that greater than 25? Yes, it is. What about these two? Is 25 plus 25 greater than 11? Is 50 greater than 11? Yes. And now these two? Is 11 plus 25 greater than the other side? Yes, it is. So it can't be 14, it has to be 25 centimeters. All right, that's all for lesson 4.3, so please jot down any questions you have and we'll go over them in class next time I see you. Thank you.